Hello everyone, my name is Purnit. I am from Department of Chemistry, IITB. So today we will be doing the lab coursework on lab coursework 415L. So here we will be separating and determining the amount of copper and iron, which are transition metals, using cation ion exchange column. So for that we will be using a resin. So here we will be using the resin Amberlight 120. Amberlight 120. So we will be using the resin to fill in the column. This is the column we will be using. Then I'll be first I'll be explaining all the things which we will be using here. So this is the column and this is an road. As you know, this is cotton. This is the resin which we have already which will be adding to the column. Then this is conical flask. You can see this is conical in shape. This is conical flask, and this is beaker. It's 200 ml beaker we'll be using, and this is a test tube. This is dropper, and this is potassium cyanoferrate, which will be used as an indicator later. Then we have HCl solution and phosphoric acid, and of course distilled water. So this is the setup for separating both the ion, this entire setup using the column and all. And here we have the setup for titration. So we will be using K2Cr2O7 and sodium thiosulfate as using for titration. And this is the funnel. This is burette to analyze, like to determine how much amount of uh, solvent we'll be using to quench the reaction. We will go into that in the second step of the entire experiment. So initially we will prepare the column. That is the first step of this entire experiment. So for that we will use approximately some amount of cotton, as you can see, and then we will add in the column. Use the iron rod to press the cotton firmly. It should sit properly in the column. Once cotton is placed, we will use we will take the resin and we will add the resin slowly. We will keep a funnel. We will keep a beaker so that we can add it. So once the resin is added, we have to wash the column with distilled water. As described, we should wash at least 3 to 4 times. We have done washing multiple times. So this is the column after washing, and we will be given a unknown solution which contains both transition metals, copper and iron. So we can see. So initially we have to add the unknown mixture to the column very slowly. Once it is added, we can place the conical flask below, and then slowly make sure that it is adsorbed to the column. Then we have to take 150 ml of phosphoric acid. So this is a measuring cylinder. We'll be taking 100 ml initially. phosphoric acid will be added slowly to the column so that we can separate the iron from the mixture, unknown mixture. Make sure add the uh, phosphoric acid very slowly so that you don't disturb the upper layer of the column. We can always check the whether iron is coming using potassium cyanopyrate. Take a bit in a test tube. This is potassium cyanopyrate. Using a dropper, you can see that there is color change from uh, colorless to bluish in presence of adding potassium cyanopyrate, which indicates that iron is still coming on the from the column. We are collecting iron. Let's let's check once again whether iron is still coming or you can see that the amount of iron coming is very less. Color is uh, very light. So check one or two times once the if it is not completely faded. You can see that already iron is completely we have collected all the iron. So potassium cyanopyrate is a indicator. Then now we will collect the copper using HCl, 1:1 HCl. We will use another flask for collecting that. So next step, we will try to isolate the copper from the notion using HCl. So we will take 100 ml of dilute HCl, add the HCl just like previously what we done. Keep a fresh conical flask and start collecting. We can check the presence of copper using same. We can see it is already yellowish color solution is we are collecting. Element is yellowish in color. Take a bit. You can see the color change of the solution from light yellowish to some orangish color or a little bit orangish. So let's check once more whether the presence of copper by using potassium cyanoferrate. You can see it is very light, so copper is almost over. So using the resin, we have separated both copper and iron, and now we will go to the next step, which is the determination of how much copper and iron was there in the unknown mixture. So for determination of iron, first step is to make sure that the amount of element is decreased to 25 ml. So we are keeping it in on the hot plate so that the water will evaporate. So this is the copper solution. Right, first we already know that we have used HCl for collecting copper. So this is acidic right now. So we will use ammonia, aqueous ammonia, to neutralize the solution. But so once the solution become neutral, you need to add dilute acetic acid to make it slightly acidic. So we have weighed potassium iodide 3 grams. So we'll be adding that to the slightly acidic solution. You can see that there is slight color change to orangish. Now iodine will be starting to liberate, so we will keep cover it and then keep it idle for 10 minutes. So while the our copper is sitting idle, we will fill the burette with sodium thiosulfate using a funnel. This is a funnel. Make sure the knob is closed and add sodium thiosulfate. So the liberated iodine is titrated against sodium thiosulfate. We will be adding sodium thiosulfate slowly to the solution, which is right now brownish yellow in color. Once the color changes from brown to yellowish, stop the titration and then add starch, which is an indicator. While adding starch, you can see that the color will change to blackish or dark in color. Once this is added, then you slowly titrate against sodium thiosulfate again. You can see that the dark color is fading. Stop when it becomes clear. It's almost clear. So now the color is already clear. So now the reading is 9.8, 9.9. We started from 10. So the reading is 9.9. You can see it is 19.9. So the reading is 9.9. So we have finished the estimation of copper. Now we will be doing the estimation of iron in the solution given solution. So first we will fill the burette with K2Cr2O7 0.05 normal. Make sure the burette is closed. So after cooling it to room temperature, cooling the iron solution to room temperature, we will add concentrated HCl. Be careful while using concentrated HCl. Add equal amount of HCl compared to the iron containing solution. So once we add concentrated HCl, we will keep it in a hot plate to make sure that the temperature is 70 to 90 degrees Celsius, and we will add stannous chloride into this. So once it is heated to 70 to 80 degrees Celsius, add stannous chloride dropwise. So once the color faints to light yellow, we can stop addition of stannous chloride, and we need to keep it in under running tap water to cool the solution. So once the solution is under in room temperature, we need to remove the excess SnCl2 by using HgCl2. We will be adding 10 ml of HgCl2 by taking in a measuring cylinder. Add it in one shot. So once addition of HgCl2, you'll get a whitish, milky, silky white kind of turbid solution. If you are getting gray or black color, you should stop the experiment right away and start from the beginning. So now, once the after the addition of HgCl2, we will be uh, titrating against K2Cr2O7 using N-phenyl anthranilic acid. One second, N-phenyl anthranilic acid as the indicator. Add N-phenyl and anthranilic acid, 5 to 6 drops. So now we are starting this titration with K2CO2O7. Add K2CO2O7 slowly. So initial addition of few drops, you will get a change in color to slightly yellowish. Then add slowly K2CO2O7. You can see that the color completely changed to brownish. So then you note the reading. We started from 10, now it is 12. So 2 ml is the uh, reading of for the iron. So as a summary of the entire experiment, we have separated both ions, copper and iron, and then we did titration to determine how much copper and iron was present in the unknown mixture. We use sodium thiosulfate as for titration for copper, and we use K2CO2O7 for titration of iron. We use starch as an indicator, and in for copper, and for iron we use N-phenylanthranilic acid. We saw the color change in both the solution. Now we have to calculate how much amount of iron and copper was in the solution. Thank you.